Cool, cool, cool. So we have been at a state where is the thing on? Yeah, it is. Cool. So we have been looking at some things and we've been running into some issues because we cannot parse int, for example, because it is not only a number assignment here, but it might be a number of or a reference to an already existing value as well. So we might say it might be an assignment or it might be an assignment from value. Because, or from reference, you'll see. Since, as you might have seen in the previous one, that we might run into these things, or we might say something like, it's not narrowing things down, but almost at the end that you can see we can assign values and we can assign references, let's say, already existing values here and there. So we should differentiate this thing, and hopefully it will resolve some of the issues here and there. So this should be a string because we have to refer not to one of the values, but something which has been hopefully stored in the hash map, and we will get back to that part. Yeah, so the operation, whenever this is this thing, we should read this thing based on the reference and reassign it to the target that we wanted to work with. One another thing here, that we should create this thing. So based on this thing, if it is a digit, then we should create this version of it. But whenever it is not, we should create the other way, with a reference. So we should say match this thing, and we don't have to unwrap it because we can say we can have. Ooh, let's see how smart this GitHub thing is. Ooh, it's already better than I am. I was just joking. Cool, looking good. So it was one of the issues. I mean, we resolved one or two things, but from now on, and I will practice my amazing drawing skills. So we will add variables here and there. But what if we would reference something sooner? I mean, we have the lines here with all of we have all of the lines here, and what happens if we would reference something sooner here, that, I don't know, add the age value, and the age is, I don't know, here. No, like 100, I don't know, 23 should be stored under the age, and we would use the age. This is an age exactly. What is use the age as the value that you want to assign to x. So we should do something about it, and what I think that we should do iterations. Yeah, this is the universal international sign of iterations, but we should do some iterations, which would mean put it into a try-catch block and try to brute force things and apply them if you can. If you cannot, you should try it in the next iteration, and you might be able to do that. Coming back here, yep. So this thing might not even be a for loop, because we don't want to, we should try it multiple times. Maybe we will run into infinite loops and such. But maybe we should try these somewhat multiple times. So how can we do that? So we should use the operations and the values. I mean, we will apply things to the values, but based on the operations, we should apply the operation whenever the operations sub things, I mean these things, are present already in the solution or the values. So we should do something like this, and I will write some pseudocode here, which I will delete soon. So try to calculate all values. If not possible, try again. If not possible, try again. If not possible, try again. This is today's best motivational speech. Thank you, Copilot. We will try again. So we should do something like while, a really wild thing. So we should go. So as long as the operations are not empty, and we should do it the Rust-ish way. So we will say something like that, do an infinite loop, and we will do some breaking things at the end or somewhere along the road. So whenever the operations is empty, break. I mean, that will be the end of this thing. And we should probably put an if here. So this is the exit condition, but we should try to apply and go through all of the operations. So we should do something like let mute current operation almost should be, yeah, or it should be 0. I mean, we should be able to go through it, so maybe we will just call it iteration index, and we will read the current index operation, and whenever, if we did not exit yet, we should increment it, which GitHub will do for us. Current operation plus equals 1. Cool. And whenever we would yeah, we can do better. So since this is a vector, yeah, whatever. So if we would be over the operations, I mean, which is the remaining part of it, we should divide it and start all over again. So the target doesn't matter, but we are interested if the operation's values are already present in the values. So match operation, yeah, and we will have something here, I don't know, start with this thing, yeah, looking good, but in any other case, yeah. So the assignment is looking good because we do not need any already existing value, because the simple assignment requires no previous values in the operations. Yeah, the operation should be mutable if you want to remove things from those. On the other hand, there should be a few other cases. Let's go with the reference. So, yeah, so whenever we no, we don't need you. We only want to do it if it exists. And if it does not exist, we should skip it. Yeah. So if the values are already containing the thing that we are looking for, we should just create the new value and insert into the values, and we should move ahead. So let's see what's going on with the end. So the end should only work if the left and the right is in the values. After that, we should do the arithmetic operation, the end, and we should remove this operation. It should be pretty much with the left. And what else? It should be left shift, right shift. Looking good. What else? What else do we have? Not. Yeah. And we don't have anything else. So what's going on here? We pretty much did the same, but we are not rushing ahead and try to do everything at once, but we will do a brute force-ish for loop, which would want to apply all of the operations, but only if their pre-requirements, the references, are present in our values vector. What is it? Values hash map. Looking good. Let's run the tests and see what is already failing. Cool. Panicked. Ooh. Attempt to calculate the remainder with the divisor of 0. Looking good. So we should not, if it's empty, we should not do the resetting of the current index. Let's see if it actually is giving back us any value. And yeah, it will take some time, and hopefully the number of the instructions are even decreasing. Let's give it a few minutes. Yeah, the other thing that we would be able to do, if not the brute force-ish thing, then that every single time that we are appending one operation, we should place it somewhere, and whenever it has some reference, we should add that new node to a graph, and we should connect these things together, and whenever the new graph is complete, we should... Okay, it did not stop yet. It is doing things. I'm not even sure if it's doing anything. We should have been, removing things, or just, we are removing things with this options remove, and whenever the options is empty, we should, stop the thing. I will wait a few more seconds because I'm really frustrated that it is trying to print line operations, and maybe not, I don't want even the all operations, but just the length of it to be exposed. I don't even know what's the what is it called? No capture? No, stop the capture. Yeah. And as you can see, yeah, that's an infinite loop. Interesting. So at 320, how much is that? Oh, that's not good. That's remotely not good. So it has been able to apply, I don't know, like that much stuff for us, which is 13. Okay, okay. So the operations remove if contains key, left shift, right shift, not. And the index, maybe this way. Looking good. We still want to divide it by 0. Operations length. What's the length here? 8. I can only assume that this thing is correct. I mean the values, but I will come back to this thing and copy and paste it once again. It happened to me already that this thing hasn't been accurate. So when we start this thing, I want to be sure that we know the operations length. It should be yeah. Let's just comment this thing. Wait, what's that? Calculate values. Oh yeah. This is looking good. So the calculate values, this should print 339. This is the amount of lines. That's looking good. So every single instruction has been successfully read into the thing, but I do not know what's going on with the instructions. Oh, we are going through the operations and we are removing the operations. I mean, unfortunately not everything. Yes, this should be good. Why don't we read this thing anymore? Operations length. What was that? Yeah, that's looking good. So as you can see, we are going through all of the operations, which is pretty sad. And we are how do we read this thing? So yeah, this should be good. Target operations at index. That's pretty disappointing. But we are reading everything. Is it even? I will do one interesting thing here. So if the values containing, I mean the key A, we should stop because we are interested only in the value of A And if it's already calculated, we should stop. Because but it's it's not there. Interesting. Index is never 0. You should. Yeah, we are not reading. Give me a second. Oh, what is this magic? Yes, so we should be able to access a vector's 0th element. I mean, index 0 element. Stupid me. So yes. So if we would run, but yeah, there should be. What? Actually, this is a good thing. I will keep it here. We don't have to go through if we already know this element. But on the other hand, this should be able to be 0. So maybe we did just print it after the thing. Can we read 0 or not? Oh, we can. Okay, it was just a printing thing. That's quite unfortunate. I will print the keys as well, which will be the values keys. Dot clone. And yeah, come on, man. Yeah, we cannot display it, so we have to do the finicky thing here. And it is not increasing after a certain found element set. It's primitive. What's missing here? And or shift. Maybe, just maybe, we did not. But wait. Found keys. It should be the same length. Why is it not the same length here? So, yeah, I mean, it's pretty fast. I will stop it somewhat immediately. So we should find. Oh, it's too fast, and too furious, bro. So what we just wrote is not super slow, but it just. Okay. But it just stops after it found these things. Yeah. Cool. So we can do another thing as well. So we should stop whenever the value, I mean, when there are 221 operations left. Yeah, and it was found 0. Yeah, okay, I got you. Can't we have a bit? Yeah, we are still finding things here. As you can see, there are 320, probably cannot see it. So there are 325 operations left. We are adding 1 or 2, still removing some of those. Yes. Still iterating over. Yes. Yeah, and yeah, still removing things. It is 322 yet. What is going on? Remove operation. I'm quite disappointed in this thing because we should be able to find everything. What did I do wrong? Can we... I mean, we probably can do this thing with this. And we should be able to debug this thing if it's working or not with this way. So let's debug this thing. Okay, debug. So A shouldn't be found here, but let's see how it's removing all of these things if it can. So there is the loop, operations 8 left, instructions. It's pretty much the same. What is the instructions coming from? Instruction, yeah, we are creating this operation based on the instructions. There is the thing. We are removing one thing from here. Yeah, we found current operation index. Okay. Yeah, we are printing it. We are at the second one. And whenever... What? Yeah, maybe I am doing something wrong with this index. Let's see if it will come back to 0 or not. But it is, yeah, it is 0 again. It should be good. Yeah, operations still decreasing. What is going on here? Yeah, there should be still 2 operations left with the D and the G, the OG. And yeah, only 1 operation left. Operation index. The index should be 0 after that as well. We print things. We go back to the first one. That's the only operation. Yeah, you should find this. Should go to that. Yep. And yeah, the length is 0, no more operation. We found everything, or we found the A. And yeah, we just return with this thing. That's interesting. Let's see what's going on with this thing. But there's a lot of question marks here. We are running it on the... We should run it on the good values. Operations 8. Yeah, we know we have to go through the example. Yada. Yeah. 7 left. 5 left. Bro. Why are we still here? Just to suffer? I might be stupid. I'm probably stupid. Why am I stupid? What's going on here? Oh, we should put this thing first, actually, because it should have higher order. Because if we found A, we stop. won't stop. Yeah, we don't have the print line stuff. Yeah, values, whatever. You can do that as well. PBD, it found stuff. No A in it. What am I missing? What am I doing wrong? Maybe there is some... oh boy. Yeah. So, another thing can be still that we did not find any of the corresponding, what is it, pattern that can be present here or there. So not, actually, let's look at the nuts. Let's look at these nuts. Okay. What do you want to hide from us? It might be the case that can it be the case that the target is already in the values, but this thing is not? Is it possible? Because we can do the nut backwards as well. I mean, we should... What is the A? What is the... I will do it by hand. So, should find this and the... actually... that's interesting. Actually, this thing should solve our issue. And actually, we should do the reverse engineering stuff as well. So the thing is, we can optimize this thing by looking at this line, and we should or can collect all of the things which ones are correlating to this thing. Because don't get me wrong, I said that this thing can create one big graph or rule set which are interconnected, but I might be really not right. I might be wrong, yes? It can be the case. So no one said that this is one graph. Those can be two isolated or more or multiple. Actually, it can be 319 ones as well. Probably not, hopefully not. Ooh. I might have spotted something really interesting here. So, oh boy, this is not good. This is eventually bad. So, we might... Yeah. Oh boy. Man. If you are thinking about career change and in your current profession, you hate someone else, you can always go and be a software engineer because you will hate yourself rather. That's so much better. You can still hate someone else as well, but you will definitely look at something and you will feel like you're eventually stupid. So this and or might contain and probably will contain values as well, not just references. So we should say not just these if values, but we should dereference these things whenever those are here. So you have seen something like this. This is an and this is bad, because if one of those is a number. So we should say left left as number. Yeah, we will try to parse it, and we will try to do it with the right as well, and match with a tuple as left as number and right as number. Yep. So if these are numbers, silence. So if those are, both of those are numbers. No. No. I mean, that might be one case, but yes. Another case can be that only the first one is okay and the right one is an error. And another case can be if the left one is an error and the right one is a value. And target, hello? String, copy. Oh yeah, we should clone this thing here because we have been consumed places before that. Oh boy, it's getting... So the contains key, this should be the case here. So whenever they are not number values, we should try to do here, because then they are not numbers. Okay, and this should be probably the case with this thing as well. Oh my god. Okay, so we should copy this thing. Yeah, please don't look at the code. It's just bad. Match. Left as number, right as number. Should be pretty much the same. But with the other operator. Like this, and I successfully removed. Bro, I should I should switch these things, or I can merge these things, but I will not. So this should be an end like this, an end like this, and end like this, and like that one, and yeah, that's it. Let's run the code again and let's see what's going on. Jesus Christ, it has a value. Look at this thing. Oh my god. Oh my god. Oh my god. I can't believe it. Let's paste it here. Easy. First try. Cool. Oh my god. Now take a signal. Now take the signal you got on a wire A, override wire B to that signal and reset the other wires. X, use me? Wish I could know what. So that's a feature. Let's say that's a feature worth a golden star. Advent of Code 2015, 7th day. Day first solution should come up with some conventions here already. Let's read this thing once again. Now let's take the signals you got on a wire A, override wire B to that signal and reset the other wires, including wire A. Excuse me? So, so we have signals. This is the outcome of that given method that we just wrote. This thing here. Don't look at it. Thank you. That's a bad thing. So this is the values that they are talking about. So we should in the second part do something like what they just said, that we should get the A's value. We can do that definitely. Let A value, we can easily say that. Yes. And we should override wire B to that signal. Okay, we can do that. Let B. Oh yeah. So we should say values dot set. What is that? So that's a hash map. We should say put add. What's here? Oh my god. So that's a hash map. Get key value. Get mut hasher insert. So we should say the B value should be the A value. Yep. Yes. And what's the last thing? And reset the other wires. What new signal? Huh? Excuse me? ¿Por qué María? What? What? What is this? So, with these instructions, let's rerun this thing again. Yeah, it moved. Yes, so we should clone them here if we can. Yeah, oh boy, I don't know what's going on here, but let's see what's. So this should be 0 because the example is still crap. But the second one should return with something. Or I will shamelessly look that thing up because I don't know what's going on. I will remove this thing. I mean the printing, because it's slowing things down unnecessarily. It's already really slow. Is it the same? I'm not even sure what's the question. What new signal is ultimately provided to wire A? So we swapped the wire A and reset the other wires. What do you mean by reset? We should set those to. Now, take the signal you got on wire A, override the wire B to that signal. Oh, I see. So we should. Oh, now I understood. So the thing is that we should overwrite the instructions for the second thing. So here we should make it mutable, the second, and we should say instructions, and wherever the B is as the source, we should overwrite it. How to do that? So yeah, we have to do things. And before the calculate values with these instructions, with the new values, we should instructions get index of B. What is Now you have to be so smart that you think you are Mr. Copilot. I mean, yeah, we should do this. So the instruction, when we do not know what is that instruction, but we might remove it, but I don't want to remove it. I want to overwrite it. So match this B, and this should be not just the position, but the I want it to be filter where the target is B and filter.any. How can we? I should be not filter but find rather. Right? Should return an option to self. So this should be an option, and hopefully there is something which has something on its right hand side, and we should overwrite it to the A's instruction. And what's your issue? He says, yeah, you have to get the reference of it, and okay, that's something. So we might say that we want to override this thing. Yes. What is this thing here again? Yeah, I know. Ooh. So consider changing that binding to mutable reference. Bro, whatever you need. That's an instruction reference. Yep. I can't do this. Oh boy. Okay. Sure. Maybe we should overwrite it as an instruction rather, where it is this thing. But this should be the same as overwriting its what is it? Operation, just like this, but we can't do this. So since these instructions should be overwritable, we should be able to say something like this. Instructions should be equivalent of its reiteration, but we should map this thing. Listen to me. Easy. Whenever can use a matching thing here. I think I'm over engineering this a little bit, but we will see. So whenever the target is B, we should overwrite it with this thing. And if it's not, we don't want to do it. And we should, yeah, so we recollected it, we overwrited the instructions. We should rerun the calculation with the new instruction set, like this. And it should be values, and we want to get the new values. Lord in heaven. I'm gonna be, yeah. I'm just disappointed. We have another number. Well, let's see what's going on with that new number. Okay, let's see. Oh boy, yeah, let's look at a code. Yeah, don't look at a code, just comment it. We will not refactor anything. We will shamelessly add everything and say goodbye. So feed advent of code 2015, 7th day. I mean, second solution. The day will be, I mean, it will be always a day. So maybe we should say 7-2 or like this. No, this looks like a date. Jesus Christ. 7th day. Second solution. And yeah, that's a solution. Jesus Christ. Yeah, meet you in the next one and have a better life. Bye bye.